Okay, hello guys. Welcome to another maths lesson. Today we are continuing on with scientific notation. So can I get you to jot this down in your books? Obviously today we are learning about, once again, how to use scientific notation in problem-solving situations. And it's actually the same one as the previous lesson. So we'll still be converting between standard and scientific notation. We're going to be recognizing when you use positive, when you use negative indexes for your scientific notation, and we're going to be using scientific notation in problem solving situations. So if we can do all those things at the end of the lesson, give yourself a big pat on the back because you are where you need to be. So once you've got that down, we'll move on. So just pause it if you need. Okay, let's review. So we're just going to do some converting to scientific and some converting to standard here. So on the left hand side, can I get you to convert those four numbers to scientific notation? And on the right hand side, convert those four numbers to standard. So pause the video, have a go at those, and once you've done that, check out the answers. So for the first one, you should have got 5.6 times 10 to the 3, 8 times 10 to the negative 4, 6.3 times 10 to the 5, and 3.4 times 10 to the negative 6. And then on the right hand side you should have got 945,000. On the next one you should have got 0.00041. On the third one you should have got, what's that, 6,600,000. And on the final one, 0.000107. So if you got all of those right, very well done. If you didn't, have a think about which or where you went wrong. Did you just count your zeros wrong? Did you mess up a decimal place? What is it that didn't quite work out for you? Okay, on to a couple of practice ones. So we're going to be looking more at the problem solving side of using scientific notation now. So what that means is we are actually looking at regular maths equations, but instead of using the regular form number, the standard form number, we're going to use the scientific notation form of the number. So just getting used to using scientific notation in an equation. This is something that you can use for any equation ever. You can convert a number into scientific notation if you think it'll be easier to use than standard. Okay, so an average person blinks 15 times a minute. How often would someone blink per hour? Well, let's create an equation to solve this. Blinks per hour will just be blinks per minute times 60. If you do it a certain amount of times in a minute, you're going to do 60 times that in an hour. So subbing in our values, blinks per minute was 15, 15 times 60, and if you put that into your calculator, you should get 900 blinks per hour, roughly. Okay, so if we put that into the scientific notation, 9 times 10 to the 2. A number like 900, I wouldn't worry about putting it into scientific notation normally, but just because we're practicing doing it, we're going to do it here. Okay. Given the previous answer, how often would a person blink per week? Okay, well we know how many per hour. So if we know per hour, we can figure out per day. Obviously I'm going to ignore the fact that you don't blink when you're asleep. That's not going to be something we worry about. So blink per hour, which is the number we have, times it by 24, that'll be how much we blink per day. And if we take that number and multiply it by 7, that'll be how much we blink per week. So blinks per hour times 24 and then times 7 will give us how many blinks per week. Sub in our numbers, 900 or 9 times 10 to the 2 times 24 times 7 gives us 151,200. And in scientific notation, that number would be 1.512 times 10 to the 5. Okay. So, as you can see, guys, all we're doing is we're just doing regular problem solving. We're presented with a problem, we need to figure out what to do to get to the answer. And in this case, we just multiply the numbers through. Cool. Let's have a go at another one. So this is a guided practice one, so I'm actually going to get you guys to have a go first. I want you to have a go solving this. If you're not sure, I'm about to go through it in a minute, but I want you to at least have a go at writing out an equation before I have a crack at solving it. So, yeah, pause the video, have a crack at A and B, and then unpause once you think you've got it. Okay, let's go through the answer. Sorry, I'll just disconnect the screen because I haven't done that yet. Sorry if it makes a really annoying noise. Okay, so we want to solve this problem. A cargo ship has 3.8 times 10 to the 6 meters cubed of space for cargo. An average shipping container takes up 30 meters cubed of space. How many containers can a cargo ship hold? So, okay. Whoops, sorry I didn't select my pen, that's embarrassing. I'll tell you what, guys, technology, sometimes I'm not a fan. Why is it not? Oh, I think I have to enable editing to do that. Sorry, guys. Yeah, that should work now. Sorry, yeah, because I emailed this to myself, it automatically stops me from being able to edit it for some dumb reason. I normally remember to turn that on before I start doing the recording, so my apologies. Okay, so we want to figure out how many of these containers will fit inside the cargo ship. So the number of containers will just be equal to the total space divided by the space per container. The reason that is that imagine you had, I don't know, imagine if we just did a simpler version of this, if the container had 100 meters cubed and the ship had 100 meters cubed of space and each container took up 10 meters cubed, that's pretty obvious that you'd be able to fit 10 of those containers in there, because 10 lots of 10 meters cubed is 100 meters cubed, and that's the available space. So in other words, 100 divided by 10 is how much we can have. So if there was 100 meters cubed and there was each container took up 2 meters cubed, you just do 100 divided by 2 would give us 50. So the total space divided by the space per container. So the total space is 3.8 times 10 to the 6. And we want to divide that by the space per container, which is 30. Now if we put this into our calculator, what do we get? Calculator. Okay. This is a bit of a finicky answer. So in my calculator, I got 1.26, and it goes 6, 6, 6, 6, 6. So I'm just going to put a little dot above the 6 to show that it's recurring. And then multiplied by 10 to the 5. So quite a lot of containers. So if we put that in standard form, times it by 5, move the decimal place 5 spots, not times it by 5. I don't know why I said that. Approximate. So the ship can fit approximately 126,000 containers in it. Obviously that would still be like 666 there, but we won't worry about that. 126,000 containers roughly. Okay, so that was question A. For question B, a company ships 9.5 times 10 to the 9 meters cubed of cargo yearly. How many cargo ships would they use over the year, and how many containers would they use in total? Okay, well there's really two parts to that question. There's the number of ships and then the number of containers. So, the way we find the number of ships, it'll be very similar to the one before. We're just going to take the total cargo. Cargo is a funny word, isn't it? cargo. I wonder where it comes from. It's beside the point, we're doing maths. Total cargo. We're going to take the total cargo and divide it by the cargo per ship. So total cargo is 9.5 times 10 to the 9. And the cargo per ship is 3.8 times 10 to the 6. Now, I don't actually have my regular calculator with me, so it's really hard to do these scientific notation things in my head. So I'm going to cheat a little bit. What I'm going to do is I'm going to do 10 to the 9 divided by 10 to the 6, which, using our index laws, will be 10 to the 3. And then I'm just going to use my phone to do the other bit, because it's fine for doing calculations like that. So 9.5 divided by 3.8. 2.5 on the nose. That's handy. 2.5. So I'm just going to write it out because I just want to know what number that is. 2.5 times 10 to the 3 will be 2500 ships. So that company is going to have to hire 2,500 ships per year. And then the number of containers that they're going to go through per year will just be the number of containers, the number of ships, times the containers per ship. And that's going to be 2,500 times, and we figured out before, about 126,000. 12600, and that number, 2500 times 12600. Now, because I got rid of that recurring decimal there, the answer will be slightly off, but that's fine. 31,500,000 1,500,000, which in scientific notation would be 3.15 times 10 to the 1, 2, 3, 4, 5, 6, 7. 7. There we go. Okay. Let me know if you managed to get those answers more or less. Like I said, there might be some rounding depending on what you did with that recurring decimal. So our answers might be a little off, but they should be in the same ballpark. So yeah, like I said, let me know how you went with that, and then there should be a handout that I've given you. If not, just yell at me and I'll grab it for you. And have a go at that. Okay, thank you very much, guys, and I will see you next time. A little bit awkward that I finished before I actually stopped the video, but there we go. Stop recording.